Welcome to the multivibrator. In this video, I am going to discuss about the topic collector coupled astable multivibrator. Before going to start the topic, let me see the basics of multivibrator. What is meant by multivibrator? The electronic circuits which are used to generate non-sinusoidal waveforms are called multivibrators. Now you can see the term multivibrator. Multi means many, vibrator means oscillations. This circuit which produce many oscillations in the form of non-sinusoidal, that is called as multivibrator. So this multivibrator is nothing but a two-stage amplifier operating in two modes. The modes are called states of the multivibrator, and the design of the multivibrator look like a two-stage amplifiers. The two transistors can be back-to-back connected. So the output of the first stage is fed to the input of the second stage, while the output of the second stage is feedback to the input of the first stage. Okay, so that is what I'm given. The output of the first stage is fed to the input of the second stage and vice versa. Basically there are three types of multivibrator: astable, bistable and monostable multivibrator. And in this video I am going to discuss about the concept collector coupled astable multivibrator. So before, what is meant by astable multivibrator? So astable multivibrator is nothing but as this multivibrator does not require any external pulse for the transition. Okay, so it is also called as free running multivibrator. So this multivibrator has two states. Both the states are called as quasi state. There is no stable state in the astable multivibrator, and that is what I am given. It has no stable state, it has two quasi stable state, and it does not need any external trigger pulse to change the transition, because this astable multivibrator transitions from one quasi stable to other quasi stable without any external triggering pulse. Yes, now this is the circuit diagram of collector coupled astable multivibrator. Just see the circuit here. One small correction, please note the correction, sorry. This capacitor is called as C2. This capacitor is called as C2. I forgot to mention this capacitor is called as what? C2. Please note it down. Here there are two transistors, Q1 and Q2. Okay, so this Q1 and Q2 are identical NPN transistors, and here the two collector resistance RC1 and RC2. R1, R2 are the biasing resistance to provide the DC bias, and this C1 and C2 are the capacitors. So VV1 is voltage across the base of Q1, and VV2 is voltage across the base of Q2. VC1 is voltage across the collector terminal of Q1. VC2 is voltage across the collector terminal of the Q2. And this one is called as VCC, power supply. Okay, and this is the circuit arrangement. Now you can see the working of the collector coupled astable multivibrator. So please take down this 3 point. This astable multivibrator has two state. Both the states are quasi stable state, and there is no stable state. And how the state can be changed from one quasi to another quasi? It does not need any external trigger pulse to change the transition. So this transition may be changed depending upon the capacitor status. Okay, so that is what important. So let me see the working principle. You can see the Q1, yes, this is called as Q1, right? So the collector Q1 is coupled to the capacitor C1, and it is given to the input of Q2, and the output, the collector of the Q2 through capacitor C2, which is given to the input of the Q1. So both the transistors are back to back connected. So to understand the working, assume that the state is Q2 on and this Q1 is off. Okay, assume that the Q2 transistor is on condition and this Q1 transistor will be off condition. So what will happen? So this capacitor C1 starts charging towards VCC power supply RC and C1 and the Q2 will be on. Finally, the voltage across the capacitor, okay, the voltage across the capacitor C1 becomes equal to VCC power supply with proper polarity. Okay, so again repeating, when Q2 is on, Q1 is off, this capacitor C1 starts charging towards RC, VC and C1 and automatically the Q2 will be on condition. So this is a one state, and when the state can be changed, at the same time this capacitor C2 which is charged to VCC in the earlier state, and this C2 starts to discharge through the path RC2 and C2, through the path VCC, RC2 and this C2, right? So the base of Q1, yes, this is the base of Q1, right? So this base of Q1 is initially minus VCC, is initially what? Minus VCC, but this C2 starts discharging and it becomes less and less negative, that is becomes more positive. Finally it becomes VB1 will be equal to cut-in voltage. So the cut-in voltage can be given as V suffix gamma. Okay, so this VB1 will be reached the cut-in voltage, and after reaching the cut-in voltage the transition can be changed. What will happen is this Q1 will be on and this Q2 will be off. Clear? This is the simple concept. When the VB1 is reached the cut-in voltage, automatically the transition can be changed. This Q1 is on and this Q2 is off condition. So what will happen if this Q1 is on and Q2 will be off? Okay, simple. Again the same process. This C2 start to charge. The C2 is start to charging through the path VCC, RC2 and C2, right? At the same time this C1 is start to discharge. So when it is going to discharge, this VB2 will be less and less and will be less and less negative. So finally this VB2 reaches the cut-in voltage. Once it reaches the cut-in voltage, again the transition can be changed. What is the next transition? Q2 is on and Q1 is off, and this process is going on. So this is the operating principle of collector coupled astable multivibrator. Now you can see the graph output waveform of this collector coupled astable multivibrator. At initially the Q1 will be on and this Q2 will be off. So this is the condition. So what will happen? Okay, as I told before, if Q1 is on and Q2 is off means, yeah, you can see this VB2, this VB2, yeah, sorry, this VB1. Yes, and this VB1 will reaches, this VB2 will reaches the cut-in voltage, and when it is reaches to cut-in voltage, it is the Q2 is on and Q1 is off. And similarly the next one, this VB1, it can be reaches the cut-in voltage and it will be Q1 is off and Q2 is on. So that is the exact concept of this collector coupled astable multivibrator. And now we are going to the value of time period t. So this is the expression for time period t. So let me start the concept, and the output voltage V0 base voltage at B2 can be given as V0 equal to Vf minus of Vf minus Vi into e power minus t by tau, where Vi is the initial value of VB2. That is what initially I explained before. The VB2 value should be given as minus VCC, and the final value of VB2 can be given as plus VCC. So now substitute the value VI and VF in this equation. So I can get the answer as V naught equal to VB2 VCC minus of VCC minus of minus VCC, right? So here 2 VCC will be there. You can take VCC as common in this equation. VCC into 1 minus 2 power minus tau. Yes, this minus T by this tau value can be given as R2 and C2. So minus T by R2 into C2. So from this equation, I am going to apply some values. Here the switching time T equal to capital T2 and VB2 equal to V gamma. So this V gamma can be given as cut-in voltage. Now apply all this equation in this, all these values in this equation. We can get the answer as V gamma equal to VCC into 1 power minus 2E minus power of minus T2 by R2 and C2. So to get T2, we should apply this cut-in voltage equal to 0. So 0 equal to VCC and this term. So from this equation I am going to find out the value of T2. So what is the value of T2? So after a simplification process, the T2 value becomes 0.693 R2 and C2. So T2 equal to 0.693 R2 into C2. Similarly, T1 equal to the same value 0.693 R1 into C1. So the total period is T equal to T1 plus T2. So 0.69 into R1 C1 plus R2 C2. If R1 equal to R2, C1 equal to C2, what will happen? T1 equal to 1.386 RC, because 0.69 into RC plus RC 2 RC. So 2 into 0.69, 1.386 RC. To find the frequency, F equal to 1 by T. So 1 by 1.38 RC, 386 RC is the value of F. So this is the expression for time period. So T equal to 1.386 RC. Thank you.